Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In trans-1, 4-dimethylcyclohexane, the two methyl groups are on opposite faces of the ring-trans relationship. In a chair conformation, at positions 1 and 4 of cyclohexane, if one substituent is equatorial up, the other at position 4 is equatorial down, since positions 1 and 4 are related such that their equatorial bonds point in opposite vertical directions. This means both groups can simultaneously be equatorial in the trans isomer. Moving on to the next step. The most stable conformation of any substituted cyclohexane places the largest possible number of substituents in equatorial positions, because equatorial positions minimize 1, 3 diaxial steric interactions. For trans-1, 4-dimethylcyclohexane, the trans relationship is compatible with a diequatorial arrangement, both methyls equatorial, which is the most stable conformation. Moving on to the next step. Option C shows a chair conformation where H3C is equatorial on the left carbon, C1, and CH3 is equatorial on the right carbon, C4, representing the diequatorial trans arrangement. This is the most stable form. And for the final step. Option A shows one equatorial and one axial methyl group, which is less stable than diequatorial and actually represents one of the two equivalent chair conformations of the diaxial diequatorial flip, but depicted here as a mixed arrangement, this is less stable. Option B shows both methyl groups axial, diaxial arrangement, which is the least stable conformation due to severe 1, 3 diaxial interactions. Option D shows one equatorial and one axial arrangement, again less stable than the diequatorial form shown in C. The stable, most stable, form of trans-1, 4-dimethylcyclohexane is the diequatorial chair conformation depicted in option C. Therefore, the correct answer is C. Therefore, the correct answer is option C.